Good morning, everyone. How's it going? Welcome to the second day of Next and to our encryption breakout session, Keys to the Kingdom. Thank you so much for coming. My name is Marcus Hartwig. I'm a product marketer here at Google Cloud Security. And it's now official. Data is the most valued resource in the world. It's actually ahead of oil, according to The Economist. But I think that most of you people here in the room will agree with me when I say that not only is data just a valued resource, it is in fact something that is quite critical for most businesses. And that's why it can pose such a huge risk if it were to be processed or handled or operated upon in a way that goes against compliance and regulation, or if it was even misplaced or leaked somewhere. Now, here at Google Cloud, we've designed and built our cloud from the ground up with security and privacy in mind. We have a wide variety of features and controls to help you keep your data secure in Google Cloud, and we truly believe that the best place and the most cost-effective way to secure that data is to have it in our cloud. Now, one of the most powerful controls that you can have when it comes to data security is, of course, data encryption. We offer data encryption for data in transit, data at rest, and data in use. Now, encryption of data in transit is really valuable if you want to protect that data as it moves from your devices to Google Cloud. And encryption of data at rest is really important when you want to protect the data that is being stored in Google Cloud. But equally important is protection of data in use. With protection and encryption of data in use, you can protect your data as it is being used by Google Cloud services. And that's really important because you want to be able to use your data as it stays secured for things like indexing or training or inference of AI and ML models. So data encryption, in a nutshell, is essential for protecting your data from unauthorized access. But it's really only as good as if you have control over the encryption keys that sort of lock in that encryption of data. Now, we offer a wide variety of features and controls for key management solutions so that you can select the one that best fits your organization and your own needs. But not only that, we also want to make it easy and intuitive to use so that anyone can take advantage of these offerings and security controls, even those who are not cryptographers at heart, so developers or regular just cloud users for us. We've made a large amount of very, very good increments and product improvements to our KMS portfolio over the year, and we're incredibly excited to tell you about them. So I'd like to invite Nelly Porter on stage, and she can tell you what we have going on. Welcome, Nelly.
Thank you so much, Marcus.
At least we clapped that.
Hello? Thank you so much. Can you hear me, first of all, everybody? OK. Thank you so much for coming. I'm Nelly Porter. I own encryption end-to-end in GCP in Google. And today, I am going to tell you a lot of interesting stories. So story number one. My customers coming to us and saying, OK, Google, we need to not only protect our data with your very important encryption keys, but we also need to make sure that we can perform the basic data lifecycle operation, like delete my data, or do data retention policy, or wipe out my data. And again, for all of you that brave enough to attend our session, understand that encryption is probably the best tool to accomplish that. Because instead of hunting for every single file or single object or every single table in data sets, you can simply delete the keys and get this data deleted. But then you need to own those keys. And it's exactly what we want to offer you with our cloud key management solution. So as you would expect from Cloud KMS, no surprise, we're really solid cloud and mature native service. We have ability to be global whenever you want us. we actually have not only global deployment, but reliability, scalability, availability, the whole things that you need. Very recently, we announced new services in area of transparency, and it's called key tracking, and it's absolutely trivial. All of you told us, okay, we need to ensure that those keys is actually associated with those objects. How do I know that those objects is actually protected by those keys? And some of you, not you in the audience, decided to go and delete some keys without very clear validation that then you actually destruct your data. And destruct your data such way that it's not recoverable. So being able to see, being able to track the keys and resources that those keys protecting is critical, and we have this capability for you. But as usual, we don't stop there. And again, what we were thinking about, and it's one additional customer told me, Nelly, it took me actually 2 months, in 2 seconds, to put 2 objects under the cloud bucket. And it was like, it's impossible. 2 months and 2 seconds. And they said, yes, here's the story. To create the key, you need to have the biggest admin in the world, key admin, creating those keys. And it happened in Europe. Again, some of you from Europe. The vacations is really, really long. So when my developer came and trying to put these 2 objects under the bucket, the key was not ready for them, because to create key, you need to have this very powerful key admin creating this key for this developer. So it took us 2 months and 2 seconds to create this key and unblock this developer. And we're like, okay, our current experience is exactly as you see on the screen. Select the key, because this key have to be created by this key admin. But what we're thinking about, the creation of the keys, is something that everybody in your organization can do. But you need to define the policy and what type of key, what type of cryptography you need to go. Is it what type of, again, rotation policy, everything. So it is why today we're introducing key management autopilot. And it's exactly what you expect. Key management autopilot is actually learn from all of you what keys you're creating day and night. We understand with confidence of 99.99999% that it's exactly the keys that you need. And we will create those keys for you on your behalf, with you fully controlling what keys and how to manage those keys. We also will support and continue supporting key managed encryption keys, or CMAC as we call, when you control every single step on the way. But we're adding those autopilot keys for you, so your developer would not wait 2 months and 2 seconds to put those objects under the bucket, and would be able to continue what they need in line with their resource creation. And let me show you the experience that you will have. And let me see that it's playing. So instead of selecting the key, you will have ability to surprise, create the key. And we will create this key, and we will create this key the best that we have in our possession. And it will be hardware-based, HSM-based keys. And you would be able to update it, change it to do what you need. You would have all of this power in your hands. And you will not spend significant amount of time of creating those keys. And also, after those keys will be created, sorry, the video is slightly out of sync, you would be able to see it in our key tracking dashboards that those keys are created. So welcome to Key Management Autopilot. We're absolutely looking forward for your feedback, and it's the service that we will offer in preview, and we will bring it to general availability very soon. So it's actually something that customer told us, Nelly, it's taken us quite a bit of time to create all of those thousands keys, and we're spending years. So we actually a lot experiment, and we love a lot of data. So we sent our developers to figure out how long it will create one key, how long it will take them, even people that know this stuff, to create this key. Approximately 10, 12 minutes. So Marcus, do you know how many keys we're actually creating per year?
It's going to be hundreds.
So actually, tens of millions of keys. So take your 12 minutes, multiply by, again, let's take 25 mil of keys. We're coming to 586 years. We spent it over 6 centuries on key creation operation. We, next year, going to give all of this time back to you. So those key admins finally would be able to take vacation. And don't worry that the organization will stop, completely stop of doing what they need. So scenario or use case or story number 2. Our customers saying, okay, keys are fantastic, but we need really, really strong protection of those keys. We have software protection, and we have hardware protection. And NIST is recommending that hardware keys are becoming more of default or preferred option for our customers. So what we will do, we actually have a service for all of you called Cloud HSM. And Cloud HSM, let me bring it to the screen, is actually exactly what it said. It's ability for us to generate and perform our operation in boundaries of Cloud HSMs. And usually when you hear about Cloud HSM, those numbers is thrown at you. FIPS 140-2-3, L2, L3, and it's like a bunch of numbers. For some of you that are joining this session, probably you have very clear understanding what is the differences. But I want to make very clear point here. The difference between L2 and L3 is tamper evidence and tamper resistance. And tamper evidence in normal human language, sorry, we're trying to translate it a little bit, means that when things happened and somebody modify or get, again, malicious access to those devices, after the fact, the devices will report to you and saying, congratulations, this happened. Tamper resistant means that those devices are built such way that they will resist those changes. And it's a huge difference. It's why we in Google believe that when we're talking about hardware, we're really talking about those very strong HSM capability. Next story, customer saying, fantastic. So we have hardware protection, we have software protection, we have things, autopilot keys. But now sometimes we need to hold our own keys close to us. We need to have ability to keep and generate those keys and perform the operation on those keys outside of Google Cloud. And we here, and we delivered, we have what we call Cloud External Key Manager story. And it means you would be able to do it outside of cloud, perform your cryptographic operation, and keep your keys for yourself, managing by yourself. With the same experiences that we have today with customer-managed encryption key. Autopilot keys will not be supported for EKM. So, and then, Cloud EKM is also adding very important capability. We called it key approval justification. When you have ability to tell if you accept the access to those keys or not. So you're putting the whole entire policy layer here to make decision if you allow us to perform this operation based on our justifications that we provide, or you actually deny access to the keys. So you're not only holding those keys in this cloud EKM capability, but you also have the entire policy level and controls to say what to access and what are not. Great. So then my customer said, fantastic. We have ability to protect our data at rest. But cloud and Google is not the graveyard. We need this data to be processed. We need this data to be used for our Gen AI models. We need this data to be used for our training, our serving. It's all what we need. So how we will ensure that the encryption capabilities that we have at rest will continue to be preserved when we're trying to process this data. And then Google in 2020 introduced a first product in confidential computing space. And confidential computing space allow us to provide very strong isolation capability. So when you bring in your workloads to us, you have this virtualization isolation capability that's provided by our hypervisor. With confidential computing, using extensions of CPU of those vendors, we started with AMD, and by the way, Intel is coming as well. We're able to create cryptographic isolation between different tenants and between you and us, Google, to ensure that our 0 days will not be able to interrupt or influence what is happening in your workloads. And it is done because of keys. But those keys is the best keys that you want to dream about, because it's created by the ASIC, this, again, silicon device that we have on our motherboard, by AMD or, again, other vendors. And those keys are stuffed into memory controllers. So we were able incredibly fast to encrypt, decrypt our memory when application trying to access it. And after the data is decrypted, it's put on the bus lines for CPU to perform operations. And after that, it's encrypted back, so it's always encrypted. And the beauty of this system is that your application doesn't need to change. As soon as it's running in those boundaries, in this confidential computing environment, in those TAs, it completely can access everything that it needs to access. But as soon as you're trying to do exactly the same operation outside of boundary of your confidential environment, you will see ciphertext. But the keys, as I said, is paramount. It's ephemeral. It's never stored. It's unique for your confidential environment. And it's also, the most important fact, not exportable. And it means not us, Google, not you, our dear customers, would be able to get access to those keys. It's the best keys to have, in my opinion. So we introduced confidential VMs. And after that, we bring to you confidential GKE, our Kubernetes managed services, Google Kubernetes Engine, to ensure that you would be able to create the whole entire cluster of those confidential environments or confidential nodes or node pools associated with this cluster. And after that, customers said, okay, fantastic, but what about Hadoop? What about Spark? What about Beam? What about all of these data analytics services? We also process so much sensitive data there when we need to do what we need to do. Where's the confidentiality in that? And it's why we also brought to general availability confidential data proc. Think about Spark, Hadoop, MapReduce, and exactly what you ask, confidential data flow, our Beam. Ability for you to prepare your data before you will be doing inference, training, or anything else with that. So we said, thanks God, we have all of that, but it didn't stop right there. Story number 5. Customer said, Nelly, fantastic. Thank you so much for isolating us so well. We not only isolated through virtualization layers, but also through cryptographic layers. But we need to collaborate. We need to collaborate among multiple companies, and sometimes those companies is actually competitors. So we can't join the data. We can't do confidential match. What do we do? And it's exactly what we've done by introducing confidential space. Confidential space is a capability that built specifically for those customers that need to join sensitive data that they couldn't do before. We have very interesting customers that are doing money laundering validation because you can't figure out money laundering or double spend if you're only processing your own data. You need to combine the data from multiple financial companies, financial institutions to be able to do that. But how you will do it, because all of them compete with each other, none of them trust each other. So confidential space is a solution for this problem, because confidential space, in addition to integrity and confidentiality, it's offering protection against workload owner. It means irrespectively if you're running this workload, you would not be able to modify it. You only would be able to start it and kill it, nothing else. And it's how you would be able to guarantee that all of you would be able to communicate and collaborate securely. So, fantastic. One more thing I forgot to mention. One more announcement that we want to make. More than 2 years, we're working with fintech companies as they're trying to bring to the cloud the payment applications. And it's everything we ask our customers to do when they're changing the environments. We're asking them to lift and shift their application and bring it to the cloud. And we're also asking them to lift and shift the data to bring it to the cloud. But the question is what to do with those HSM devices that you need to perform your payment operation, because those payment HSM is very special devices. Please don't leave them behind. We're offering a new service in GCP called Metal HSM for payments. And the idea of this service is exactly what you will ask. We will take those HSMs from your hands. So PCI certification is actually changed recently, allow you to remote administer those boxes. And it means you can pick them up if they support remote administration and bring it to us. And we will do what we need to do with those wonderful devices. And it will be a fully certified facility with all of our expertise to help and take care of those devices. You also can go and buy those HSM from your vendors, because we strongly believe you have strong relationship with those HSM payment companies. So what we will do, because we will bring it in our Google extensions, we can guarantee that the latency of those operations will stay exactly what you expect. And it's the most important thing. And it's physics. It's speed of light. You need to bring the boxes closer to your workloads to ensure that it has not more than 8 milliseconds latency. We want to ensure that we will be scalable, reliable, and helping you to bring your payments applications and your payment HSM together. We also will be able to work with you if you have to bring general crypto HSMs as well. So we are not only talking about payment HSMs, but it's probably the most critical ask that we hear from all of you today. And I'm done. Back to you, Marcus.
Thank you so much, Nelly. Now,
because I'm staying.
None of these hardware-based solutions would have been possible whatsoever without our technology partners. And we are lucky to have 2 of them here today. So I'd like to invite Todd Moore and Adam Cason on stage from Thales and from FutureX.
Hi, everyone.
Thank you so much for coming.
Good morning. Where do we stand?
Let's change.
You gotta stand under your picture, Adam. Yeah, there you go.
Good, now you're matching. So, Todd, would you mind just taking a minute and tell us a little bit about Thales, for those who are not familiar? I know we go way back between Google Cloud and...
Sure. So good morning, everyone. From Thales. For those of you who don't know who Thales is, we're a large global company based in Paris, France. We do a lot of different things. We build satellites. We were part of the Mars rover project. We build airplanes and submarines and things like that. We also have a very large digital security business where we do a bunch of banking cards, credit cards, as well as cybersecurity, and that's where I'm from. And we've been working with Google for a very long period of time.
Yep.
Really appreciate the partnership. We're a Google customer, Google Cloud customer, and I think what we found working with Google is we had a lot of expertise and a lot of things that Nelly talked about in terms of external key management and HSMs. We're really focused on digital sovereignty. Being a Paris-based company, a European-based company, we get asked, how do you meet digital sovereignty requirements around the world? So leveraging some of the constructs that Google has, we've been working together for a long time. We kind of, I think of it as a yin-yang. Google's really good at what you do from the infrastructure perspective, and we try to bring what we do from an encryption and key management perspective, an external key management perspective. So thank you guys for having us here.
Yeah, thanks for coming. Adam, FutureX, one of our newer partners in the portfolio, I would say.
Absolutely. Well, thank you, Marcus. Thank you, Nelly. It's been a pleasure being here. So my name is Adam Cason. I handle partnerships and alliances at FutureX. And what we do is focused primarily around enterprise key management, data protection, hardware security modules for both payment and general purpose. But as far as the Google relationship here and our focus there, we've centered that around a few different use cases. Cloud EKM that we've talked about here today, Google Workspace, client-side encryption as well, and also the bare metal HSM for payments that we've discussed today. So, we're looking forward really to discussing those and how all of those interplay with one another and form really an overall ecosystem here.
Thank you so much for coming as well. So we've talked a lot about payment customers and what makes their needs so special when it comes to hardware security modules as opposed to any other customer. And I'd like to direct that one too, Todd.
Sure. So from a payment HSM perspective, and this is an exciting time with Google, is there's really three, payment HSM is a specialized HSM, and it really, I guess, three characteristics. And Adam, love to hear your opinion as well too. But it really is around payments and compliance. You hear about PCI. The payment industry is always updating the regulation and compliance. You got to make sure that your HSM as a part of that compliance chain is certified to the latest standards. So compliance is a very big, important part when it comes to payments. The second element, and Nelly touched on this, is speed. It's latency. So a lot of folks, all of us, when we go buy something with our credit card or our phone, we expect that payment transaction is going to happen relatively quickly. And it's just one use case, but you want the latency and the time for that to be relatively quick. So there is a latency component. And I guess the third aspect when it comes to payment functions, and they are very unique, is you want your applications not to change. I mean, there are payment applications out there that have been around for a long time. As you write new applications, you want a very robust API, application programming interface, so that your legacy applications as well as your new applications can interact with those new payment functions. So payment HSM is a unique beast, I guess I would say. And as Nelly had said earlier, customers have asked us, how can we leverage our legacy payment applications, get performance and latency, and be able to get the compliance in a cloud environment? And with bare metal, I think we're being able to do that with Nelly. So, but Adam, I might go ahead. I wouldn't steal any thunder there. No,
that's honestly, it's spot on. I think you look at the compliance, you look at the speed. Those are two big areas of very, very important focus. Payments and the use of hardware security modules in payments is one of, if not the oldest use case for them. And so there's a lot of legacy history behind all that. A lot of reasons why things are done certain ways, from key management, from processing, from algorithms, key derivation methods, all these different things. But I think two additional things that really matter in payments more than a lot of other areas. Workload confidentiality, data criticality is important. Every organization has their own type of data, no matter what vertical you're in, that is that mission critical data. Payments, though, you're dealing with data that crosses not only your own organization's boundary, but also a lot of other stakeholders out there. You've got the card issuing bank, you've got the organizations that process that data, you've got merchants, you've got the end consumer with their own payment data. All of that, in the event of a breach or anything like that, there is a lot of splash damage from that. And the risk factors that come from that and the desire for everybody not to end up on the front page of the Wall Street Journal really is why the payment HSM ecosystem exists in the way it does. One of the reasons why, as Todd said, compliance, PCI, FIPS, like Nelly was saying earlier, are so important is just packaging up everything in a way that matters from a compliance standpoint. But one of the other things we're seeing these days that I think is particularly interesting is a convergence of different data types and different means of data protection almost into single ecosystems, where you don't as often nowadays see people dividing out workloads or data types into payments or general purpose or their PKI. Really forward-thinking organizations are viewing those as part of the same overall ecosystem. And so now seeing what's going on with Metal HSM for payments, building on some of the other confidential computing, cloud HSM, cloud key management, all of this fits into the same overall ecosystem. And I think looking at it from that direction really is what we're seeing trending-wise.
Anything to add, Nelly? Or?
I think they said it all.
Okay, but let's take a step back. And why are, you think about hardware-based controls, why are they so important overall in this space? And I'll let you start, Adam.
Fair enough, yeah. Well, I mean, building again on what Nelly said earlier, it's all about that tamper evidence and tamper responsiveness. The idea being that you take your cryptographic keys that are protecting your most sensitive data, really whatever that data is. The data type doesn't even matter. But you take the keys that are being used to encrypt that data, to validate that data, to sign that data, and you house those keys inside a tamper-evident, tamper-responsive ecosystem. You ensure protection not only from outside threats, this handled using the algorithms, the cryptographic techniques that we're all familiar with, but you also protect from insider threats. You protect from tampering with that physical device itself, as such that nobody, even people in your own organization, even your most trusted security admins and employees, have no way to ever get to those keys in the clear.
Yeah, no.
Todd,
I was going to react. No, that was good. Good point. I agree with everything you said, Adam. I guess whenever you talk about hardware-based controls and HSMs, the first H in HSM is hardware. Just, so it's pretty evident that we want to make sure that we're really protecting our, and very important, critical keys, as you said, Adam, and hardware. And so I think having the right set of controls, and we all hear about different types of breaches and hacks that occur, where a lot of those very important credentials and encryption keys are in software, and it's easy for hackers to get those. And once they have it, they have the keys to the kingdom, as we call this session today. So I think hardware-based controls are important, not from a compliance perspective, but also just from a best practice, a best security practice perspective, to make sure that you put all that critical information inside that safe called an HSM and hardware. So, Nelly?
Thank you so much, Adam and Todd. The only thing that I will add, hardware also have really small, what we call trusted computing base. The amount of software or the amount of firmware that running in hardware controls is very limited. And as a result of that, as usual, as more stuff you run, as more stuff you need to trust. With hardware and hardware capability, and with firmware and this very limited functions that's specifically designed for those operations, we ensure all of us that the hardware is used exactly as it's supposed to be through enormous amount of testing, pen testing, etc. And it is why we believe that hardware is providing very strong additional layer of protection for everything that we do. And it's the same not only with HSMs. It's the same with confidential computing, why we're relying on hardware CPU extension and hardware capability to create this opportunity for us to offer this functionality to you. So absolutely, hardware is interesting. With combination with the right software and firmware, we provide really strong security assurances for all of you.
Excellent.
Now, Nelly, we talked a lot about making this more accessible and intuitive to use. So what would you say, what are some of the sort of things we're doing to make the complexity of a data security strategy a little bit more on the table for most organizations?
I think key management autopilot is going to simplify your life enormously. And we're absolutely looking forward for your early feedback on this capability. Because again, cryptography is complicated. And I'm sure all of us love to talk about cryptography, but making any mistakes in this space is really creates huge consequences. And the second one, usability without security is absolutely not even the same. Again, I can give you a few millions of examples when fantastic security never provided, first of all, protection, but also it didn't meet their expectation, and probably something that you're super familiar with. It's called multi-factor authentication. Huh? We love multi-factor authentication. You know how many years we as security community trying to ensure that our users, our customers are not relying on passwords alone? I don't know, probably 20 years, 25 years. And it's still, again, so complicated to have this second factor and third factor and whatever N factor available for us, for employees, for users, for everybody. So security and data protection without usability simply would not fly. It will not work. And this is why Google was one of the first that trying to make confidential computing as well usable. Compared to whatever was possible before, it was a lot of security and very few attention to usability. Now the whole industry is working to ensure that your applications do not need to change. The way how you operate machinery doesn't need to change. And we creating the environments that will fit your needs instead of otherwise around. So we absolutely paramount on making this usable for you. And we will continue to listen to your feedback and make our story even better.
Well, I'll just, thanks, Nelly. That was perfect. I'll just add that I think Marcus started off this presentation talking about data. There's so much data being generated and it's sprawling all over the place. From our perspective, my perspective, getting control of your data sprawl is through controlling the keys that are encrypting that data. You want to find out where that critical data is, you want to encrypt, you want to maintain those encryption keys. I think from a complexity perspective, it's really being able to centralize and manage those keys. And I think from all of you, it's leveraging the tools that are made available to you. So with Google Workspace, you can use client-side encryption today. When it comes to Google Cloud, we've got external key management, we've got CMEC, customer managed encryption keys. We also have the hold your own key or external key management. We ubiquitous data encryption. The idea is cloud service providers like Google give you those tools that when you're using their service, they can use the key management services as well too. So to make it maybe as a first step, and I think that was the question, Marcus, you know, how do you move in to actually coming up with a data security strategy? Leverage the tools that are given to you. Start leveraging those external key management, those centralized key management tools, and then over time you'll start to add more use cases. But the CSPs, Google in particular, is giving you all the technology that you need to really get a start when it comes to protecting your information from a data security perspective. So hope that's useful. Maybe too high level, but Adam, go ahead.
No, yeah. I would agree with all that, and I think one of the barriers historically to implementing strong encryption and a good, robust data protection strategy has been around complexity, or maybe perceived complexity of it, and it is tough. And one of the challenging things that I've seen historically is that organizations may be very quick to buy solutions or services or things like that, but then actually developing the skill set within their employee base and maintaining that to actually handle the care and feeding of these devices, these technologies, sometimes they lag a little bit in that. And that can actually produce some unintended risks if they think they're in a secure spot, but in reality, well, maybe they're not quite where they need to be. And you know, for me, that's one of the things I'm excited about some of these new technologies, is that it takes some of that workload burden off the end customer. It says, all right, here are things that we can do that we know we can make decisions easier and present that to the end user. And I think that ultimately will result in a lot greater adoption of these technologies, a lot greater protection of that sensitive data, and hopefully a little bit of time saved along the way too.
Well, like I said before, none of this would have been remotely possible without the great partnership between our companies. So thank you so much for...
Thank you, guys.
Thank you for joining us.